Imagine, for a moment, that you're standing under the vast night sky, surrounded by a dark canvas punctuated by the soft twinkling of distant stars. Above you, light years away, stars burn bright, and galaxies swirl in their endless dance. But somewhere, out there in the far reaches of space, a mysterious signal cuts through the cosmic silence. It's like a sudden lightning bolt of energy, a fast radio burst, blindingly bright and gone in the blink of an eye. This fleeting pulse of energy can contain more power than the entire Milky Way galaxy in the time it takes for a heartbeat. Yet, in its brief, explosive life, it leaves us with more questions than answers. Where do these signals come from? How are they formed? And could something as strange and intense as an FRB actually pose a risk to life on Earth? Could these cosmic flashes reach us with the potential to cause harm? For over a decade, fast radio bursts, FRBs, have puzzled scientists, sparking theories and debates across the globe. The discovery of these enigmatic signals was a breakthrough, but it also raised new, unsettling questions. What if these bursts are a sign of something far more ominous in the universe? Or perhaps, what if they're simply part of the natural ebb and flow of the cosmos? In this journey, we'll examine the mysterious nature of FRBs, explore their origins, and carefully weigh the potential threat they pose to our planet. Are they a cosmic curiosity, a fleeting anomaly, or a force of nature with consequences we haven't fully understood yet? For much of human history, we've gazed at the night sky and pondered the mysteries of the universe. We've studied the stars, tracked the orbits of planets, and mapped the galaxies. But then, in 2007, something new and completely unexpected emerged from the depths of space. A brief but intense flash of radio waves that lasted only a few milliseconds, yet contained energy on a scale that boggles the mind. Scientists were at first stunned. Fast radio bursts, or FRBs, were unlike anything we had seen before. They were fleeting, appearing for a fraction of a second, only to vanish just as quickly. But their intensity was unlike anything we'd ever measured. The energy released in a single FRB could rival the output of an entire galaxy in mere milliseconds. This discovery shattered preconceived notions. We knew that stars emitted radio waves and that pulsars, rotating neutron stars, could send out beams of radiation. But these bursts, coming from galaxies billions of light years away, seemed to defy all our expectations. They were outliers, cosmic anomalies, brief, powerful flashes that appeared with little warning. Why, then, do we call them bursts? Perhaps it's because of their nature. They arrive suddenly, releasing immense power, and leave just as fast. But unlike a slow-burning star, an FRB doesn't give us time to study it before it's gone. The mystery deepens with each new detection. So what exactly is behind these mysterious bursts? After all, they didn't come with a manual. For years, scientists have offered a number of theories, ranging from the plausible to the wildly speculative. One of the most widely discussed possibilities is the presence of magnetars, a rare type of neutron star. Magnetars are the remnants of massive stars that have exploded in supernovae, and what's left is an incredibly dense, compact core with a magnetic field that is trillions of times stronger than Earth's own. These extreme magnetic fields can shift in powerful, sudden ways, releasing enormous bursts of energy in the form of radio waves, the very essence of what we detect as FRBs. Alternatively, scientists also suggest that black holes might play a role. The intense gravitational pull of a black hole could rip apart nearby matter, releasing powerful bursts of radiation in the process. Could an FRB be a byproduct of such a violent cosmic event? And yes, there are even more outlandish theories. Could these signals, with their staggering intensity, be the result of an alien civilization? Some have speculated that these bursts might be artificial, transmissions from an advanced civilization harnessing enormous amounts of energy. Could we be receiving signals from extraterrestrial life? While this idea remains purely speculative, it's an intriguing possibility that opens up profound questions about life beyond our planet. With so many possibilities on the table, the truth remains elusive. But every new detection of an FRB brings us one step closer to understanding what may lie behind these cosmic flashes. Now, as the mystery of FRBs deepens, many might ask, could these bursts actually pose a threat to Earth? After all, these bursts are no small thing. They contain more energy than we could ever dream of producing. Would that energy be enough to affect our planet? In a sense, we are safe. For the most part, fast radio bursts originate from incredibly distant galaxies, often billions of light years away. The immense distance means that by the time the burst reaches us, its energy has dispersed, weakening substantially by the time it arrives on Earth. When it does reach us, it's typically far too weak to have any significant impact. Radio waves, the kind emitted by FRBs, are relatively low energy compared to the types of radiation that could truly cause harm. Unlike gamma rays or X-rays, which have enough energy to penetrate our atmosphere and pose a danger to life, radio waves are much less harmful. In fact, the Earth's atmosphere acts as a natural shield, absorbing the vast majority of harmful radiation from space. So, in the grand scheme of things, FRBs are not a danger to us. But what if an FRB were to come from much closer? What if, instead of billions of light years, the burst originated from a nearby galaxy, say within just a few thousand light years? Could the effects be more severe? In such a scenario, the impact could indeed be felt more strongly. A burst closer to Earth would not have had the opportunity to spread out, and thus its intensity by the time it reached us would be much stronger. It could potentially cause some temporary disruptions, mainly in our satellite communications, electrical grids, and possibly even the ionosphere. Astronauts in space could be at risk of radiation exposure. Yet, even in this case, the damage would be localized and far from catastrophic. Could an FRB wipe out life on Earth? The answer is no. Our atmosphere would still block most of the harmful effects, and life on Earth would likely continue as usual, albeit with some technological hiccups. But even with the worst-case scenario, the global impact would be minimal in comparison to the scale of other cosmic threats, such as a nearby supernova or gamma-ray burst. While fast radio bursts may not be a danger to us, their study is crucial for our understanding of the universe. Each burst is a clue, a signal from deep space that could tell us more about the life cycle of stars, the behavior of magnetic fields, the formation of black holes, and even the nature of gravity itself. These bursts are a cosmic riddle, challenging us to think in new ways about the universe we live in. And the good news is that with advances in technology, we are getting better at detecting and studying these signals. With new radio telescopes and more refined techniques, we may be on the brink of solving the puzzle of FRBs. And who knows? In doing so, we might unlock new truths about the nature of the cosmos, revealing insights into the forces that govern the very fabric of space and time. Fast radio bursts are not just a threat to our understanding. They are an invitation to look deeper into the universe. They remind us that there are still mysteries beyond our reach, waiting to be explored, and that the cosmos is full of surprises that may one day change the course of human knowledge.